Okay, let's thinking about the ciphertext. We start with in this section, and we already calculate the length of the keyword should be 2 or 4 through the Kaczynski test. And we also calculate the IC of the message, and that is 0.047. So we can calculate R should be 2.946 through this formula in Friedman test. So at this moment, it looks like this result suggests more likely 2 instead of 4 because it's a little bit closer to 2, right? But it might happen because our ciphertext is not long enough. So we should have some possibility to have the 4 as the length of the keyword. And at this moment, let's just assume we figure out that length should be 4 instead of 2. Okay, but if you have a long enough ciphertext, it's going to be we have better chance to get the right number. Okay, so let's say we have 4 as the length of the keyword through these two tests. Then our condition was like for each column from the table that we have is going to be monoalphabetic. It's not only monoalphabetic, it should be additive cipher. So all we need is how shift each letter to get the ciphertext, right? Then you just need the Virginia square to figure out that. Okay, so for each column, we are going to take each column to get the letter for the keyword of that column, right? Okay, so our method is just checking the letter E, right, which is appears most likely, right? So in the first column, you need to calculate this by yourself. It kind of takes a long time, right, to do that, and check which letter appears most, and it turns out N. So we can guess like maybe N is the cipher letter for E in plain letter. And of course you can count how many times you have to shift to get it from E to N, or just simply checking the Virginia square and what letter is assigned in that common columns and row from E and N, right? And it turns out it's J, or E to N you need 10 digits shift, right? So or 9, it depends on one less or something like that. So we can guess the first letter of the keyword is going to be J. The second column we calculate again, and at this moment S appears most, so we can calculate again, and O is going to be the corresponding one from the Virginia square. And if it's not working after you figure out all these 4 letters, maybe it gives us the plain text. Then you go back here and assign W instead of S for E, right? And we do it again. Okay, so it's always kind of try and error style, the deciphering. In the third column, it appears O appears most, right? So corresponding one in the Virginia square is going to be K. And the fourth one, it looks like I appears the most, so it changed to that one is E. So all together our keyword is going to be J-O-K-E, joke, right? So that's how we got actually in here and this one. So when you do this part, actually we have an idea what letters is going to be here, and we don't know what these numbers are. All we need is just putting our ciphertext in this 4-column table. Why it's 4? Because from that 2 tests, right, Kaczynski and Friedman, it suggests the length of keyword is 4, so we just arrange our ciphertext like this and look at each column and count how many what letters appears most in there, right? And clearly in this column it's going to be additive cipher, so all we need is what is going to be the key, move E to that most appeared letter, and that one will give us what corresponding this keyword letter in there. So we just do each of these columns separately, and eventually we are going to get this keyword. After we got this keyword, we can breaking back this one into original one, using again this Virginia Square to get the plain whole text.